record. And we're recording. Okay, so start assessment. And the applications, a reminder, they are kind of like a little quiz where you just get one attempt on it. I had accidentally sent more than one attempt before. I think it was because somebody had accidentally submitted when they shouldn't have. But you're only supposed to get one try at each. So give your best calculation and your best interpretation. And by the way, an interpretation means to write what it means. And we'll talk about a similar example in a moment. Yeah, this one right here is you have to state your opinion. So you got to think about what it means to have a large or a small standard deviation and maybe draw out some sketches of that. And number 3 was the question at hand. I give you a situation, and then you have to think about that situation. I describe what the x-axis of the graph would look like and what the y-axis would look like. I highly recommend, like I did over here, drawing that out and trying to see what it looks like. Do some internet research if you're really feeling stuck on it. I guarantee you'll find some graphs out there with real data or hypothesized data. So this was my pea plant data, where I was looking at the heights of plants in my garden and what kind of distribution it was. And since all the plants started germinating at the same time with the same amount of water and the same amount of light, I had very few small plants. Most of the plants were in the 7 to 10 centimeter range. So this distribution, I believe, is skewed left. And so I had to use my imagination and some past experience to guess at that graph. And so that's the goal for this assignment. For each situation, consider the situation, sketch out on a piece of paper what the horizontal axis is, sketch out the vertical axis is, and then again, rethink, what is this situation again? How would I collect this data? And then try to graph what you think the data would look like. And each one is pretty similar. Could you reuse symmetric, right, skewed, to uniform? Sure, you could. But you have to have a reason why you chose that distribution. So some kind of explanation. So some other examples. If somebody has a 75% free throw chance and I watch them shoot 12 shots in a row over and over again, so like every day for a year, they take 12 shots and I write down how many they get in. What I would expect is they would get 75% of their shots in most of the time. 75% of 12 is 9, so most of the time they got 9 shots in. So this is a relative frequency histogram for someone shooting that normally shoots 75%. I would expect most of the time they're around 8, 9, or 10 shots in out of 12. Once in a while they get lucky and get 12. Once in a while they have a bad day and only get 5 in. So this distribution would be skewed left. Think about hip replacements. Do young people get hip replacements or older people? So I don't know. I know a bunch of friends that have hip replacements and they were all like 60, 70, 80 years old. So if I did some research on hip replacements or just made a guess at it, I would think the distribution looked like this. Mostly it's people in their 70s and 60s, sometimes older people like 80s and 90s, but surgeries like that for people that are old are a little more dangerous. And then very few young people get hip surgeries. So I would expect hip replacements to be skewed to the left, with most people older getting it. Tonsillectomy, what do you think about that? Do people older or younger get tonsillectomies? How many of you have had your tonsils out? Me, I was like 12, I think, when I got my tonsils out. I had one daughter that got them out at 16. Yeah, so Mindy says younger, and I would agree. From my knowledge of tonsillectomies, mostly it's young people that get them, and it's pretty rare for an older person to get it. So I would think the distribution of tonsillectomy ages would be skewed right. Yeah, so for each of these, I just want you to think about it, make a sketch. You don't need to send me your sketch, but if you want to, let's see, did I make a way to do that? I did not, but I can add that, I think. Hopefully I don't screw this up. I'm going to try and add a button that says submit work, and it's just an optional thing. So let's see, settings. I know they added that feature, display option maybe. Provide show your work boxes. Sure, during and after. So even if you already did it and you want to go back and throw a sketch in, there's now should be a button allowing you to do that. So let me just double check I didn't totally mess this up. Start assessment as a student. And now if I go into like question 3, there should be a place at the bottom for me to add my work, okay? And the check your answer is, don't count on that. You only get 1 try. Oh, shit, I accidentally gave you 3 tries. Oops, I'm only supposed to get 1. Oh, well, my bad. All right, so do your best. Don't wear out your chances. My hope was you would try this and get it in 1 shot. And all I need is you to pick the box you think, pick which kind of distribution you think it is, and then write Y for each of these. And if you want to include sketches you drew, there's now a show work, add work button where you could upload or yeah, use the, let's see, attach button here. And you could put some work on that. And each of these has it now. All right, so let's see. How do we respond right back? So after I grade it, so let me enter something in. Oops, do I want to leave that? No, I don't want to leave. Okay, so let's suppose I go in and just guess randomly, bang, bang, bang. I have no idea if these are right. I'm not even looking at them. And I'm just going to write blah. So if I submit this, blah, 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 blah. Where's the submit button go? I don't want to show work. I'm just going to put check answer. And then let's see, submit and end. Yep. What happened? It appears, ooh, I'm not done with the other questions, right? Duh. All right, so this one right here, I'm just going to close my eyes and pick a button. I missed. And blah again. And one more time. Now this one here, right, calculate the average. So what's the average here? 5, 10, 15, 20, 25, 30, 38, 40, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55. So the mean is 55 out of how many? 5, 10, 15, 24, whatever 55 out of 24 is. Google says it's 2.29-ish. I'm going to go for 2.3 for my answer. And it says, yeah, I got to enter decimal, 2.3. Has anyone ever been to a soccer game where they scored 2.3 goals? Answer is no. You could score 2 goals or you could score 3 goals. Which are they more likely to score, 2 or 3 based on this average? 2, yes, thank you for that visual there. Yeah, so what I would say, like, how would I explain that to my mom? I'd say, hey, mom, this team scores about 2.3 goals per game. She's like, Gary, that's stupid. They can't score 2.3 goals. And I'd say, oh, yeah, right, sorry. I would expect, on average, team scores 2 to 3 goals. More likely, 2 per game. So interpretation means write it so somebody else will get it that doesn't know as much math as you. It doesn't mean say, hey, the average is 2.3. I got the average by adding up all the numbers and dividing by how many. That's not an interpretation. That's a definition. Interpretation means explain it to somebody in plain language. So no statistical terms. Average is okay. Most people get that one. So that would be a good answer there. All right, so then I submit and end. And it says after submitting, you'll not be able to change. That is correct. Thank you very much. So then if you go back right now, if you look at the bottom, no, I gotta leave it and come back. Save work and continue. Thank you. All right. Whenever you come back to this, there's going to be the review work and gradebook option. And when you check that, you should see your grade. If the grade is very low, it means I haven't graded it yet. So for example, it didn't like my mean because I can't follow directions. It said 2 decimal places. And I got all those wrong, but it says this assessment contains items that are not automatically graded. If that's your feedback, it means I haven't graded it yet. Once I've graded it, you'll see a shitload of writing there. I tend to write quite a bit to people Even if yours was perfect, I'd write why it was perfect. So you will see stuff there. So keep patient, please. I'm trying to get all this done. I got a couple of classes I've never done online before that I'm barely a week ahead. You guys are lucky in that I've taught this online before, but my workload is a little crazier than usual. So I appreciate your patience. My apologies for delays. Let's see, a little confused about a uniform distribution. Okay, so let me think of another example I think would be uniform. Uniform. Okay, I have a lame example that I'll use until I come up with a brighter idea. So let's leave the student view and go back to my distributions. If I was really bored, which I'm not right now, but if I was, I might find some dice on my table and just sit there and roll it over and over and over and over and over again. And sometimes I'd get a 1 or a 2 or 3 or 4 or 5 or a 6. Well, if the dice is fair, I should get just as many 1s as 6s. So if I looked at the distribution of the percent of the number of times I got 1 and percent of times I got a 2 or a 3 or 4, I would expect that to be pretty even. Now, it doesn't have to be perfectly even because, again, there's chance involved. So if I rolled the dice 6,000 times, although I'd expect to get about 1,000 1s, it might be somewhere between 900 and 1,100. So these would be roughly the same height. So a uniform distribution is where every possible category on the x-axis has approximately the same height of the columns. And that would be a uniform distribution. And rolling a dice is one example of that. If I were to, no, it's not a good example. Man, off the cock. I'm going to put a note here, come up with clever examples of uniform distributions, and then I will post an announcement. So uniform examples. Oh, another thing I wanted to mention. This hasn't been well used in this class. Some quarters students are all over it and other quarters they're not. But every week I have a questions about page. Where's that one? Questions about week 3. So if you all get stuck on something, you should post here. So like Dakota posted something, no one replied, he answered his own question. I made a post that I've gotten lots of questions about number 10. And did anyone reply yet? Nobody replied yet. So if somebody could answer this question today, so number 2 is what people are getting stuck on. It's in one of my videos, I go over this, and then I made out a handwritten example of me doing this. So if somebody else could post here, that'd be great. You'll get extra credit if you do a good job. Otherwise, sometime this afternoon, I'm gonna post my answer to this right here for those of you who get stuck on number 10 in the homework. And I've already written back to some of you, but I got a lot of questions, more questions on number 10 than any other question. Okay, so please, if you're stuck on the application, you could write here saying, hey, on number 3, part 3, this is what I thought. I'm not, here's why, but I'm not sure. Communicate about it. You guys, this isn't, you're allowed to do that there. So help each other out. All right, let's see. It's got a bunch of chat going on here. Let me make sure I didn't miss anything. Application 3, number 3, correct or incorrect? I answered that. How do we respond back? I answered that. Oh, no, I didn't answer that. So responding back. So I grade your application, and then you see a grade, and at the bottom of the application, you see the feedback. So you'll know yours was graded when your grade goes up in the gradebook, but to actually see what I wrote about it, you have to go to the assignment, probably from the home page. Where'd you go? And then over here, there's a button that says review work in the gradebook. And then at the bottom, you'll see my feedback. So if it still says this has stuff that's not automatically graded, it means I haven't gotten to yours yet. If that's making you anxious, then send me a note saying, please, I'm anxious, grade mine now. And I usually grade them in the order they came in. And then to reply to me, what you would do is you would message me from the inbox or send me an email with any updates you have to this within a week of when I grade it. Okay, so I answered that. Uniform distribution, got that. Okay, Let's see, Charlotte made a comment I don't get. I submitted a few questions through the application. Oh, so you asked me some questions in here when you submitted it? Okay, yeah, so I'll once I get caught up on application 2 today, I'm gonna start going through application 3 early. I'm not gonna wait till Sunday because that has not worked well for me. I'm so far behind on grading, I gotta start it earlier. All right, let's see, Bailey, if we have a score of 0 on something in the grade book that we turned in with no feedback, yeah, don't worry yet, Bailey. That means I haven't gotten to it because I'm painfully slow right now. I'm trying to figure out my workflow in this new online system, but I'm getting there. So feel free to follow up with an inbox message in Canvas to me, Bailey, saying blank assignment has a 0. Can you take a look at it soon? Just to kick me in the pants. A little guilt helps me get stuff done quicker. Let's see, have you decided when the quiz will be? I'm leaning toward having it be the end of next week. So then I would open it up like Wednesday, and you could do it Wednesday, Thursday, or Friday. There's 2 parts. One part will be not timed, meaning you open it up and it'll be data you copy into a spreadsheet, and then you have a day or 2 to mess around with it before you submit your answers to it. And then the second part, and I'll make it clear, is timed, which means you do not enter the password for, and I'll give you guys a password just to make sure nobody opens it accidentally. Once you enter the password, the timer starts clicking. And usually I design the test to be like 30 to 40 minute test, but I give you 90 minutes to take it. So yeah, you can look stuff up during it, but if you spend too much time looking stuff up, you're not going to have enough time to answer all the questions. So you got to definitely be prepared, have notes ready, budget your time carefully, and do it in the time limit there. So and there should be samples available. So let me see. Let's go back to the home page. Usually I give those tests on paper, but obviously we're not doing paper tests because we can't get together. So I got a few things here. The take-home exam questions, I put a password on that. I'll give out the password next week so you can get into that. And that's the one where I'll give it out sometime between Monday and Wednesday, and you'll have till like Friday or Saturday to turn it in, as opposed to then a timed one will appear underneath here. The sample page here just has paper tests I've given in the past that you can take a look at. And your time test will be like that, but the setup will be like the homework, but you only get 1 try on each question. And then, which brings us to this online version of the practice, which is like what your test will look at, like the timed version, where you have all these different questions to answer. And the only difference is here you get unlimited attempts, but on the time test, you get 1 shot at each question. And it won't tell you how you did till the end. And then some of the questions have written responses, which means part of it won't be graded till I go in and read them all. So your grade will be incomplete on that part till I go in and read it. And the same thing is true for the take-home part. Some of the questions will be automatically graded, like calculating the average, but other questions require you to type answers and the computer can't grade those. I have to go in and read them. So there'll be a delay between you entering your work and then getting your full grade with feedback, because I got to go and read it all. All right, so where can we find the video on the 2 standard deviation rule? Good question. And what else do we got here? Question for application 3, question A and B, because you feel they could both. Yeah, so Micah asks on application 3, question 3, parts, I think, A and B, he feels they could both be uniform. So your goal then is to, in the explanation, if you choose uniform, to write why you believe it's uniform. So you have to have some reasoning behind it. And usually it takes me like 2 or 3 sentences maybe. Like if you look back at when I was messing with my pea plants, I got a bunch of reasons why I think it's skewed left. Okay, and somebody that's a better gardener than me that watches pea plants more might have a better idea than me. And maybe I should go research it. I'm sure somebody's published research. So if I did a search about pea plant heights 1 month after planting, I bet somebody has data out there. So I can't answer that question directly because it's an application, but it could be that you have a good reason that both A and B are uniform. You just have to write up that reason, and then I'll consider it. All right, let's see, what else was I just going to do? Two standard deviation rule. Okay, so I'm going to do an example of that right now, and let me find that video. So, week three videos. In the overview video, I have it in there. I'll go to that, and I can't remember if it's in the mean standard deviation video, but it's about to be in a new one.
To the right. Similarly, I could go the other way. So
all right,
subtract
so pause. That's weird. A video within a video. So about 13-ish minutes in, I'm going over what standard deviation means in the overview video. And then within a couple of minutes of this, I get to the two standard deviation rule. So a measure for outliers is more than two standard deviations from the mean. So check between 13 minutes and like 16 minutes in the overview video, and you'll see me going through that. So let's actually do an example of the two standard deviation rule. And we might as well use problem number 10, which came up a lot in the questions. So let me get to that. And most of these problems require a spreadsheet to make the calculations. I don't recommend doing any of them by hand, even for a small data set. Remember that for finding percentiles and quartiles, the by hand method is not the same as the computer method. All right, so here's the problem people had a hard time with. I give the calculations right here. But what I want to do here is I want to visualize this data in a histogram to kind of see the two standard deviation rule in action. So I'm going to copy this, and somewhere I had, let's see, week 3 spreadsheet. Where are you? Week 3 descriptive stats. And let's make a new number 10. 10 again. I'm going to paste the data in, but in order for Google to make a quick histogram, I need to paste it vertically. So I'm going to cut it out and repaste it underneath. Paste transpose flips it. So instead of horizontal, it becomes vertical. And if I have it all in one column, then Google can make a quick histogram for me, which makes my life easier. So let's get rid of those 2 rows. So what I'm doing right now is not essential for this problem, but I'm trying to help you all visualize what the two standard deviation means, two standard deviation rule means. What is this? This is mass of corn in grams. All right, so Google has this quick histogram builder that skips over making a frequency table. So I don't need a frequency table here. So I'm just going to say, hey, give me a histogram. And Google says, here's a histogram. So this data is skewed left. Majority of the data is between 10 and 25 grams for each of these ears of corn. And I'm just going to double check the mean and standard deviation here. Again, this graph is incomplete. I have insufficient titles all around, so my mom would freak over that and tell me. STD. I know this was already in the sheet, but I want to see it on this page too. All right. And standard deviation. And the recommendation here is to use stdev.s. And then highlight your data. All right, so we have a mean and a standard deviation. Let's take it down to 1 decimal point. And let's copy this into my whiteboard machine. Copy. So I'm going to draw what the two standard deviation rule means. And I think that histogram is sufficient enough. Add to new page. So the mean here is about 19. So if I mark that off, that should be right about here. So that right there is X bar, the mean, and it's approximately 19, we'll call it. Standard deviation is about 5. So if I go 5 to the right, that's going to put me over here at 24. And if I go another 5 to the right, that's going to put me at what? 29? No, am I doing that right? 19 plus 5 is 24. Yeah, 29. It's going to put me right about here. So 29. So to calculate this number, what I did is I took X bar and I added 1 standard deviation. To get that number right there, I took the mean X bar and I added 2 standard deviations. I can go the other way too. So if I subtract 5, that's going to put me over here at 14. So that would be X bar minus 1 standard deviation. And if I subtract 5 again, that's going to put me over here at 9, which is X bar minus 2 standard deviations. And what we expect is for a lot of data that there's going to be somewhere between 75 to like almost 100% of your data, depending on the data set, is going to be in between 2 standard deviations. Okay? Since most of the data is in between, it should be unusual for data to be on one side or the other. So outside of 2 standard deviations is what we call an unusual event. Unusual, another word for unusual could be rare. We rarely see data outside of 2 standard deviations. And this right there is a 9, by the way. So over on this side too, to find an ear of corn that measures less than 9 grams based on the existing data, it would be rare to find any corn out here. And another word for rare in this case is unusual. So then I have to make those calculations, and I kind of already did here. So the lower estimate for below is about 9, and the high estimate for unusual, excuse me, telemarketer here, shut up please. All right, I estimate it to be about 29. Now, are those the exact cutoffs? The answer is no. I did a bunch of rounding to make it easy for me. So based on this data, I expect most ears of corn to be between 9 grams and 29 grams. And it's unusual to find data on either side of that. So back to the spreadsheet, and you don't need a spreadsheet for this one. I just chose to use one for fun. And those numbers should match what I calculated here. Yeah, so the 18.7 and the 4.8. So the lower number is going to be the mean, 18.7 minus 2 times the standard deviation. Please stop calling me, Jesus. Oh, excuse me, sorry. I didn't mean that. 4.8. And here I have to, I can't type the calculation. I have to actually get the value. So copy, calculate. 9.1, right? So I was close in my rounding approximation. So this one would be 9.1. And then I do the same thing here, but with a plus. So change that to a plus, 28.3. So I was estimating 29, close enough, so 28.3. So if there's any ears of corn that were less than 9.1, they are unusual, they are outliers. If there's any ears of corn that are heavier, that have a bigger mass than 28.3, they are unusually heavy compared to the others. So up here, there are 2 ears of corn that were heavier. And if we look at the histogram, that shows that too. So my cutoff was over here. And it turns out there were one of these over here was too heavy and one of these in that column were too heavy. Okay. Sometimes when I make a histogram, edit chart, I'll use the standard deviation as the cutoff points. And so under histogram, I can set the width to be 4.8, and then I could start at some standard deviation below that. So hit enter. And then I would go down. So let's see, 1 standard deviation to the left was about 9.1. So now these markings here should represent my mean, 1 standard deviation below, 2 standard deviations below, 1 standard deviation above, 2 standard deviations above. And so then my chart is actually checking for me if there's any outliers. And to do that, I had to approximate the standard deviation, and then I had to find a place 2 or 3 standard deviations to the left to start counting. And if you're interested in that trick, I can record another video about it later. All right, so that is the 2 standard deviation rule. Will the 2 standard deviation rule for outliers always match the IQR rule for outliers? The answer is no. Sometimes they agree, sometimes they don't. Every data set is different. All right, other questions. Let's see, a bunch has happened. Oh, wrong way. All right, answer that question, answer that question. Okay, so anybody else have questions? Nothing here at the moment. All right, I have a question. Does anybody know or have an idea of what the age distribution looks like for people who have died from the coronavirus? Is it symmetric? Is it uniform? Is it skewed left, skewed right? So let's get my whiteboard and play with that idea for a second. Then we'll look up some data on it. New page. So what would this histogram look like? So on vertically, I'm counting the number of deaths, and horizontally, I would have ages. So age versus number of deaths. So we got uniform, we got bell, we got a couple of options. So from what I've seen so far, so let's put up some numbers here. How about we could go by 10. So 10, 20, 30, 40, this would be 50 right here. 60, 70, 80, 90 would be over here. And I'm just going to guess. So I have not heard of any young people or many young people dying. So I think these stacks would be very short over here, if any height at all. And then it would start to grow out here. So I've heard of deaths of people in their 50s, 60s. So I'm guessing the distribution looks something like this. I don't think it's symmetric. Symmetric would be that most of the deaths occur in some mid-range, and there's very few on each side. So this would be symmetric up here. You label that symmetric. Uniform would be every age group has exactly the same number of deaths, or pretty damn close. So this would be uniform. And from what I've heard is there have been very few deaths of young people. It's mostly older, and by older I mean like above 50. And so this, I believe, would be skewed left. And the skew is to the tail. So there's lots of places that have data about this. I'm going to go to the Oregon Health Authority. It's a place I've been looking to see what's going on in Oregon. So I'm going to just search Oregon coronavirus. And where's the health authority? Right there. Is that the right one? Yep. So, so far we've had 2,000 positive cases as of yesterday. They'll update this tonight. For the demographics, they have by county here, and I live in Umatilla. Where are we at now? In Umatilla, we're up to 29. Okay, so I saw that yesterday. A week and a half ago, we were at 11. So we've almost tripled in a week and a half. It's a little scary, but there's severe underreporting too. So that 11 was probably higher. Who knows if the 29 is more accurate than the 11 was. If we look at the age distribution here, and we look at the deaths, we can see there's very few deaths in the 0 to 9, no deaths, 0 to 19, 20 to 29, 30 to 39, 3 deaths of people in their 40s, 1 death in their 50s. Most of the deaths were people 80 and over. And I have that data from yesterday right here. And actually on Tuesday, I made a graph of it just to see that. And so here's a graph of Tuesday's age distribution, which hasn't changed much since today. So it's very skewed left to the tail. So remember, skew is the tail. So the question is, well, why would we say skew is to the tail? Why not do we say it's skewed right? So here's why we talk about skew to the tail. Let's go here, and I'm just going to make up some numbers. Am I in the right spreadsheet? Yeah. Oh, I was playing with that over here. Yeah, let's start over. All right, so let's suppose insert row. Let's suppose these are quiz scores. And I have what, 1, 2, 3, 4, 5, 6, 7 quiz scores. And most of the people, let's say it's out of 10. Most of the people didn't do so well on the quiz, but one person did really well, okay? Notice that the mean is greater than the median. So these are in order, the mean is the middle number there. Now the median doesn't care what the high number was. So if that number right there was a 7, the median does not care, it doesn't change. If that becomes an 8, the median's still the same. If that becomes a 9, the median's still the same. But as this upper number increases, look what happens to the median, okay? So the median in this, or the mean, excuse me, is rising. So if I make that a 10, okay? If we look at a graph of these scores as a histogram, what we see is that most of the data was over here bulked together, but this tail here is dragging the mean away from the median. In one sense, you might say that that outlier over here is distorting the average. What is a better description of how the class did? Is the 5.4 a better description or the 5? Now in this case, they're close enough to the same that it doesn't really matter. But an example I gave last week in the critical thinking exercise was home prices in my neighborhood. So suppose we look at the houses on my block, and let's suppose they're all about $100,000. So this is 100,000. But there's one big house on my block, and that's worth like $400,000, right? If we look at the mean and the median of this data, they're going to differ because the median doesn't care what the biggest number is. All it cares, whoa, what'd I do? All it cares is that I'm the number in the middle. So if I calculate those equals average and median, what we'll see is the, whoa, not median, is that the median says, yeah, the house prices are about $100,000, and the mean says, no, they're higher, 150. Now, which is a better description if I wanted to tell somebody about the cost of houses in my block? Well, I would, this $400,000 house is pretty unusual. All the other houses are modest, around 100,000. So there's a skew here. There's this tail of 400,000 that's dragging the mean away from the median. And that's one reason we talk about skew being the tail. Is it always obvious what the skew is of data? The answer is no. Sometimes there's the mean median rule, there's the look at the graph rule, and then there's some calculations one can make about that. We're not doing those calculations. You might do those in a second or third stats course. But there are ways to measure skew, just like we measure standard deviation. All right, so let's see, other questions. Back to this 2 standard deviation rule for a sec. Oregon. So up here, if we look at the age range of, so this was as of Tuesday, the distribution of ages. This is a little distorted because all of the middle columns are all the same width, they're 10 years, but the left one is 20 years, and the right one is who knows how many years, 80, there was somebody that was 102, I know that had it. But this is just the way the health authority gave me the data. They didn't tell me how many people were 0 to 10, and they didn't tell me how many people were over 90. So I can't make a better histogram. But I would say this is pretty uniform bell-shaped distribution here. And then as far as the standard deviations, I estimated the mean to be 51 years old. So the average age of people who've gotten the coronavirus in Oregon is about 51. If we look 2 standard deviations to the right, then we see an upper limit of about 89 years old, and on the low end, we see about 13. So if somebody under 13 gets it, that's weird, unusual, and rare, considering the majority of cases we know of. If somebody over 89 gets it, that's unusual too. I don't have an explanation for the under 13, but the over 89 is there just aren't many people over 89. So that's why we wouldn't see them. So if we looked at like distribution of ages in general in a population, those are relatively uniform until you get to the older ranges, and then it drops off. But it again depends. Are there the same number of births every year? The answer is no. Birth rates have been declining for a while now. So age distribution of a population is usually relatively flat up until about 60, and then it starts to taper off, coming down because people have to die. So it is interesting that younger people don't seem to get it as much as older people. Is it an immunity thing? Must be, but I don't know if we understand. I know we don't understand the details of it yet. But hopefully next year we'll know more. All right, so nobody's chatted any questions. I'm just kind of rambling here. Is there anything else you want me to ramble on? No chats. Nobody's voicing anything. So if you have no questions, then feel free to sign off. I hope you have a good weekend. Don't forget that, I'm going to leave this page without submitting. You've got the place called Questions About Week 3, where if you're stuck on something, you can ask your classmates. Or if you found a really hard problem and you got it, you could post your solution there. That's okay. So help each other out there. Critical thinking, make sure you go in after you post, read my post, read at least one more post, and then add something to your post to correct or elaborate on it. And then otherwise everything's due by Saturday, and there'll be more details about the test next week. And the test is just going to cover the first 3 weeks of stuff. And next week's kind of a light week anyway. So that's it for today, I guess. Have a great day. Good to see y'all virtually. Okay, let's check that out. Thank you, Craig. Week 3. Awesome. Oh, we got a bunch of posts there. Cool. Thank you for posting. Appreciate it. All right, have a great day. I'll see you soon. Get in touch with if you need anything.